We now come to a very new topic, which is magnetic effect of current. Now, first we need to know that the origin of magnetic field is flow of charge. So, whenever there is a flow of charge, this is associated with a magnetic field. Now, as you can understand that the flow of charge is associated with a magnetic field, hence it implies that when there is a current flowing through a conductor, this is basically a flow of charge which involves a magnetic field. Now, this existence of the magnetic field due to a current was first discovered by Oersted with help of his famous experiment. As he placed a needle below the current carrying conductor, he found it to be got deflected. Now this deflection, as he explained, was due to the cause of the magnetic field, which creates a force on the pole here and hence deflecting the needle. So the first man, in order to explain this whole phenomena of magnetic effect of current, was this man Oersted. So Oersted experiment is very important as far as this magnetic effect of current is involved. Now later on, many other scientists went on to study the magnetic effect of current. There were very great names like Ampere, like Laplace, like Biot. But finally, those two scientists together, Biot and Savart, were able to clinch the whole issue as they were able to provide the magnitude of the magnetic field induced along with the experimental proof. So this law, which we state as Biot-Savart law, is actually a law which is also somewhere referred as Laplace's law. Because, you see, the Laplace was another scientist who also went on to calculate the magnitude, but unfortunately he was unable to give the experimental proof of the whole thing. So this is also sometimes referred as Laplace's law. Now, according to the Biot-Savart law, if there is a current flowing arbitrary conductor, we have an elementary length segment del L here, and then we have a distance measured from this elementary length segment R, and there is a point P where we set the magnetic field B. Now, this angle between del L and R is what we mention as theta, and we can find that B is directly proportional to I, that is the current flowing in the circuit. B is directly proportional to the sine of the angle, that is sine theta, and B is also directly proportional to the elementary length segment del L, and it varies with inverse square law. So all these four variations are part of the Biot-Savart law, which states that whenever a current carrying conductor is taking a current, it induces a magnetic field at a distance r from the elementary length segment del L of the current carrying wire, which is given by B, and B varying with so many parameters. Now this variation of B, when we put it in the SI unit, the B, as we can write with a constant here, it is mu naught by 4 pi I del L sin theta by r square. Now this I del L sin theta by r square is given by a unit, the field unit in SI, which we call the Tesla. Now the mu zero is what we call the permeability of free space, and this is basically the measurement of the lines of force, the magnetic lines of force that are allowed through a medium. So permeability of free space, as we calculate this value, it happens to be 4 pi into 10 to the power minus 7 Henry per meter. So that is very important. The unit is Henry per meter. As you can see, the permeability has value of 4 pi 10 to the power minus 7. So mu naught by 4 pi happens to be 10 to the power minus 7. Now this is very important for us, as we are going to replace mu naught by 4 pi repeatedly in problem. We can directly replace it by 10 to the power minus 7. Now finally we need to learn the vector form of Biot-Savart's law, which is very important, as the del L parameter is considered as a vector here. So we write it like this, that it is a dB, the elementary field due to the elementary length segment. That is why it is put as dB, which is I del L cross R. Now it's very important, rather a convention that we put del L first and R later, and then that is del L cross R, R cube. So as you can find, that's del L cross R. When del L cross R, we write it as del L sine theta R. This R and R cube goes scratching, making it R square, and here it is I del L sine theta. So that is what we are writing the force in vector form. That's all for now, students. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.